Hello everyone, so our question is 4-point charges minus q plus q plus q and minus q are placed on y-axis at y is equals to minus 2d, y is equals to minus d, y is equals to plus d and y is equals to plus 2d respectively. The magnitude of electric field E at a point on the x-axis at x is equals to d with d, capital D, very greater than small d will behave as. Our options are E is inversely proportional to d cube, inversely proportional to d, inversely proportional to d raised power 4 and inversely proportional to d square. Okay, so the given data in the question will, if we will represent it in figure, it will look like this. Okay, so the figure look like this. Okay, now the electric field due to the charge minus q placed at a distance of plus 2d and minus 2d will be same. Okay, and similarly the electric field due to the plus charge plus q and plus q at a distance of plus d and minus d will be same. So let us suppose that electric field due to plus q will be equals to E1 and electric field due to minus q as E2. Okay, now the distance of minus q placed at a distance of 2d will be equals to, this distance is given to us is how much? Capital D, correct? This distance is given to us is capital D. So this distance will be equals to 4d square plus d square by using Pythagoras theorem, and this distance will be equals to d square plus d square, correct? Now E1 will be equals to kq upon r square, correct, which is d square plus d square, and E2 will be equals to kq upon 4d square plus d square, correct? Now due to the charge plus minus q, the electric field will act as E2 in this direction, and due to the minus q placed at a distance of minus 2d, it will be E2. So the net electric field at the point, let us suppose it is A, so the net electric field at A due to the charge minus q will be 2E2 cos theta 2, and due to the plus q it will be E1 and E1. So the net electric field will be 2E1 cos theta 1, correct? Now so what we can write from here, that the net electric field E is equals to 2 times E1 cos theta 1 minus 2 times E2 cos theta 2, correct? Now from here we can write 2 E1 we have calculated as kq upon d square plus d square into cos theta 1. Look at the triangle of the cos theta 1. What we can write from here, this angle is how much? Theta 1, correct? So cos theta is base by hypotenuse, base is capital D and hypotenuse is under root d square plus d square. So it will be capital D into under root of d square plus d square minus 2 times E2 is kq upon 4d square plus d square into cos theta 2 will be d upon under root of 4d square plus d square. Okay, now taking 2kqd as common, what will remain is 1 upon d square plus d square raised to the power 3 by 2 minus 1 upon 4d square plus d square raised to the power 3 by 2, correct? Now taking d square common from here, what we get is 2kqd upon d cube into 1 upon 1 plus small d square upon d square raised to the power 3 by 2 minus 1 upon 1 plus 4d square upon d square raised to the power 3 by 2, correct? Now since we have been given that capital D is very greater than small d, correct? So using the binomial expression, what we can write from here is 2kqd upon d cube into 1 upon 1 plus 3 by 2 small d square by capital D square minus 1 upon 1 plus 6 small d square by capital D square. Correct. Now taking LCM, what we get is 2kqd upon d cube into 1 plus 6 small d square by capital D square minus of 1 minus 3 by 2 small d square by capital D square divided by 1 plus 3 by 2 small d square by capital D square into 1 plus 6 into small d square by capital D square. Correct. Now since small d is very less than capital D, correct, so the ratio d upon capital D will be less than 1. Correct. Or what we can say that d square upon d square will also be very less than 1. So what we can say that this term will be equals to 1 and this term will be equals to 1. Okay. So what we will get is 2kqd upon d cube raised into, so from here plus 1 and minus 1 got cancelled out and this will become 9 by 2 small d square by capital D square. Correct. So from here what we get is 9kq upon small d square upon d raised power 4. Correct. So what we can say that our electric field E is varying inversely proportional to d raised power 4. Correct. Now checking out from the options, what we get is our option number 3 is the correct option for us. Okay. Thank you.
Hello students, we have a question. 2 point charges Q1 as under root 10 microcoulomb and Q2 negative of 25 microcoulomb are placed on x-axis at x is equal to 1 meter and x is equal to 4 meter respectively. Now the electric field on y-axis at a point y is equal to 3 meter we need to calculate. So in this we have a situation that we have two axes. This is y-axis we have and this is x-axis we have, and in these two axes we have the two different charges, that is Q1 at 1 meter from the origin and we have another charge which is negative in nature minus Q2 which is 4 meter from the origin, and we need to calculate the electric field at a point which is 3 meter on y-axis. So this is a situation we have. Suppose this is a point P. So due to this charge Q at point P, we will experience an electric field, and this electric field will be in this direction. We name it as E1. This is the vectorial direction we have for E1. Now if we consider that it is making an angle theta 1, so we will have the two components of this E1 as E1 cos theta 1 minus I cap, because it is negative to I cap. Now if we talk about this component, so this will be E1 sin theta 1 plus j cap. Now if we talk about the next charge, so we have Q2, and this Q2 negative will make an experience at point P of the electric field as this way. This is we have E2 vectorially, so it will have two components of it in these two directions. Now if this is theta 2, so this will be alternative angle as they are parallel lines. So it will be E2 cos theta 2 positive I cap. Now if we talk about this component, it will be E2 sin theta 2, and this will be negative j cap. So this is what we have the situation. So first of all we will find the values as per the magnitude, and that magnitude we can see that E1 will be in magnitude will be 1 upon 4 pi epsilon naught Q1 upon R1 square. Now where is R1? This is what we have, R1, which is equal to under root of 3 square plus 1 square, that is under root 10. If we talk about R2 here, so R2 will be under root of, taking the triangle of theta 2, the big triangle, we have 3 meter and 4 meter. So it will be 3 square plus 4 square, which will result in 25, or we can say 5 meter. So this is what we have, R1 and R2, the position vectors. So on putting the values, we have the value 9 into 10 to the power 9 as of 1 upon 4 pi epsilon naught into Q1 we have under root 10 into micro coulomb divided by R square we have under root 10 whole square. So this is what we have, and on solving we are getting 9 into 10 to the power 9 minus 6 into under root 10 divided by 10. So this is what we have the value, and this is the value of E1 in only magnitude. If we talk about full vector of E1, so it will be the magnitude and the multiplication of magnitude with the two components of unit vector. So these two components we have sin theta 1 j cap plus cos theta 1 minus I cap. We can see the situation in the diagram. We are talking about this and this unit vectors. So this is the situation we have. So again we are writing E1 is equal to 9 into 10 to the power 2, and this 10 will be cancelled and we will get under root 10 here, and the value inside we have, in place of sin theta 1 and cos theta 2 we, and this 3, this is under root 10 and this is 1. So the sin component we will have 3 divided by under root 10 j cap, and this is negative, so I write negative here, and it will be 1 upon under root 10 I cap. So this is what we have E1 value. Similarly, we will find out the value for the E2. So E2 in magnitude will be equal to, we can see that E2 value is 1 upon 4 pi epsilon naught. We will add 1 upon 4 pi epsilon naught into Q2 upon R2 square. Negative just represents the direction, so we have introduced in the coordinate system, so we are not taking here. The value is 9 into 10 to the power 9 into, and the value we have 25 microcoulomb, so it is 25 into 10 to the power minus 6 divided by R2 square we have, so we directly write 25 here, 5 square. So 25 is cancelled out, and 9 and minus 6 results in 10 to the 9 into 10 to the power 3. So we have the magnitude of E2 to be equals to 9 into 10 to the power 3. So this is what we have, volt per meter. The magnitude, volt per meter. Now if we talk about its full vector, so it will be E2 multiplying the unit vectors with this. So we have, now we are taking another triangle, and this triangle is having angle theta 2. The given values are 3 meter, this is 4 meter, and this we have 5. So we write here the value as, term will be cos theta 2 I cap. As we can see, this is cos theta 2 I cap, and this is minus j cap with this value. So we write these two values as cos theta 2 I cap minus sin theta 2 j cap. On putting the value, we are getting 9 into 10 to the power 3, and we have inside value as, we talk about cos theta 2, so it will be 4 divided by 5, and if we talk about sin j cap, sin theta 2, so it will be 3 divided by 5. So, and the unit vectors are also there, j cap, I cap and j cap. So we have these two values. If we needed to find out the resultant, which is ER, so we need to add these two vectors as E1 plus E2, the full vectors. So the expression we already have, and for adding we need to add up. For adding we make it more simpler, and on adding we are getting the final expression, that is 9 into 10 to the power 2 taking common, and the addition and subtraction after we are getting this expression. Now on further solving we are getting this 9 into 10 to the power 2, and in bracket we have 7 I cap minus 3 j cap. Now we are getting this as 10 to the power 2, and multiplying 9 we are getting this much. So this is what the final expression we are getting for the resultant electric field experienced at point P. So option A is the correct answer of this problem. Thank you.
Hello everyone, let us start with our question. In this question, what is given? Charge Q, 2Q and 4Q are uniformly distributed in three dielectric solid sphere 1, 2, 3 of radius r by 2, r and 2r respectively as shown in the figure. Now if magnitude of the electric field at point P at a distance r from the center of the sphere is given as to be E1, E2 and E3, we need to find the correct order of magnitude. Okay, so first of all we find the value of the electric field E1. Okay, so for E1, for E1, P is outside this sphere. Okay, so this would be behaving just as a point charge. So we can say that electric field would be equals to 1 by 4 pi epsilon, and the charge is Q, divided by what is the distance from here to here? It is r, so it would be r square. Now E2 value we calculate, so it is again on the surface of the sphere, so we can just treat it to be a point charge. We can just write the value as 1 by 4 pi epsilon, and the charge is 2q, divided by distance is r square. Okay, now for the third case, So it is lying inside the charge for this inside this sphere. So we can say that our E3 would be whenever a charge is lying inside the sphere. So E3 is given in terms of the this charge density rho as rho r divided by 3 epsilon. Now where rho is the volume charge density, r is the radial location, which in this case is capital R. So we put the value of rho. Rho is what? Rho is the volume charge density. So volume charge density means what is the total charge? Total charge divided by volume. Total charge is 4q. 4q divided by volume would be what? Volume would be 4 by 3 pi into r cube. Radius is 2r, so 2r cube into this. What is the radial location at which we need to find the electric field? It is r divided by 3 epsilon. Now if we solve this, then our E3 value would turn out to be 1 by 4 pi epsilon. Okay, it would be q divided by 2 r square. So here itself we write the value of E2 which we have got. E2 value turns out to be 1 by 4 pi epsilon 2q divided by r square. And our E1 value turns out to be, E1 value was 1 by 4 pi epsilon, then q divided by r square. Now if we check this, okay, which would be the correct order of relation? So maximum value would be what? Maximum value would be our E2. So we say that our E2 would be greater. Then which comes? So it would be E1. And then what would be coming? It would be E3. So this is the order. So E2, then 1, then 3. So which is the correct option for our case? So E2, then E1, then E3. C is the correct option. Hope you understood the solution. Thank you.
In this problem, we have given that 6 charges of equal magnitude, 3 positive and 3 negative, are to be placed on PQ, RS, TU corners of a regular hexagon such that the field at the center means O, okay, is double that of what it would have been if only one positive charge is placed at R. Which of the following arrangement of the charge is possible for PQ, R, S, T and U respectively? Okay, so we have given that to find the electric field at the center, and there is only one positive charge, and consider the magnitude of charge is Q. Okay, so we know that electric field can be given as KQ upon R square, and from all the corners the distance of the corner to the center is same and magnitude of the charge is same, so electric field will be considered as E. Okay, so say the electric field at the center is E. Now let's talk about the direction. So due to positive charge, the electric field always acts away from the positive charge, so the direction of electric field at the center will be in this direction. So in this case we can see that at the center of the electric field, the direction of electric field is this and magnitude is E. Okay, now let's talk about the options given here. Okay, so we have given 4 options over here. So let's start to arrange the charges and find that O, the net electric field is 2E, because it is given that this would be double of the initial. So starting from P, so this is positive charge. Okay, option A, according to option A, Q is also positive, R is also positive, S negative, T negative, U negative. So we can see that due to positive charge at P, the electric field will be in this direction, say E. Due to Q, the electric field will be in this direction, say E. Due to R, the electric field will be in this direction, and consider this is also E. Due to S, this is negative charge, so electric field will be attractive, and this is E. Due to T, the electric field will be attractive because charge is negative E, and due to U, the electric field is attractive, this is also E. So we can see that at O the electric field is 2E in this direction, 2E in this direction, and 2E in this direction. So the equivalent of E equivalent at O is not equals to 2 times of E. So we can say that option A is wrong. Now again we are going to arrange the charges according to option B. So let's talk about option B. So in option B, at P there is charge negative, Q is positive, R is positive, and R is positive, S is also positive, T is negative, and U is negative. So due to negative charge at P, electric field will be in this direction. Due to Q, the electric field will be in this direction. Due to R, the electric field will be in this direction. Due to S, the electric field will be in this direction. Due to T, the electric field will be in this direction. Okay, and due to U, the electric field will be in this direction. And obviously at O, this is not equals to net electric field, that is 2E. So this option will also be wrong. Now let's talk about option C. So again we have option C, that is negative charge at P, positive charge at Q, then positive charge at R, negative charge at S, positive charge at T, and negative charge at U. So due to negative charge at P, the electric field will be in this direction. Due to positive charge at Q, the electric field will be in this direction. Positive charge at R, the electric field will be in this direction. Negative charge at S, the electric field will be in this direction. Positive charge at T, the electric field will be in this direction, and negative charge at U, the electric field will be in this direction. So we can say that this E will cancel this E because they are opposite in direction. This E will cancel this E because they are in opposite direction. So at O, the net electric field will be existing in this direction, and that is equals to E plus E, that is 2E. So we can say that in this condition the electric field at the center is 2E, which is double of the former. So we can say that option C is correct. Okay, now let's talk about option D also. So if we are talking about option D, so we have given at P the charge is positive, Q is negative, R is positive, S is negative, T is positive, and U is negative. So due to positive at P, the electric field will be in this direction. Negative at Q, the electric field will be in this direction. Positive at R, the electric field will be in this direction. Positive at T, the electric field in this direction. Negative at S, electric field in this direction, and negative at U, the electric field in this direction. Now in this case we can see that this is also not equals to 2E. So we can say that the option D is also the wrong answer. So only option C is the correct for this problem. Thank you.
Hello students, our question is an electron of mass me initially at rest moves through a certain distance in a uniform electric field in time t1. A proton of mass mp also initially at rest takes time t2 to move through an equal distance in this uniform electric field. Neglecting the effect of gravity, the ratio of T2 by T1 is nearly equal to. The solution for this is electrostatic force. Electrostatic force E will be equals to E into E for both particles. Okay, E will be E into E for both particles, but acceleration of electron and acceleration of proton will be different from each other. So acceleration of electron AE will be equals to FE upon ME upon ME. Okay, ME FE upon ME, and acceleration of proton will be equals to FE upon MP. Okay, so if we find S will be equals to half AE into T1 square. Okay, and S will also be equal to half AP T2 square. Okay, so S is equals to half AE. These both are equal, so it can also be equal half AE T1 square will be equals to half AP T2 square.
Okay, so half will get cancelled out, and T1 upon T2 will be equals to T1 upon T2. So we have to find the ratio of T2 upon T1, sorry, T2 upon T1. So T2 upon T1 whole square will be equals to AE upon AP. Okay, and we know the value of AE and AP. So T1 upon T2 whole square will be equals to AE is FE upon ME whole upon FE upon MP. So FE will get cancelled out. Okay, 1 upon. So sorry, it is T2 upon T1. T2 upon T1. So from here we can clearly find out the ratio of T2 upon T1 will be equal to whole under root MP upon ME, and this is our answer. So in options it is whole under root MP upon ME. This is our answer.
Hello everyone, welcome to Dotnet. So in this question there is a charge small q that is placed at the center of the line joining the two equal charges capital Q, and it is given that the system of the three charges will be in equilibrium if a small q is equals to, and we have four options, q upon 2, minus q upon 2, q upon 4 and minus q upon 4. Okay, so suppose this is charge capital Q and this is charge capital Q, and in between them this is charge a small q. Okay, as you can see, this small q charge will experience electrostatic force from both the charges capital Q. Okay, so a small q will already be in equilibrium. So all the system, so the whole system will be in equilibrium in case if if any of the capital Q is in equilibrium. So suppose this distance is, let's say this distance is small r and this whole distance is 2r. Okay, then if suppose this capital Q charge is in equilibrium, then the whole system will be remain in equilibrium. Okay, so the force on this capital Q because of this capital Q will be like this, let's say F Q. Okay, and because of this small q, there should be a you can say there should be a attracting force, okay, in this direction to balance the force of capital Q. So let's say this as F small q. Okay, so since this distance is also r, will equate F capital Q should be equals to F small q. Okay, so F capital Q will be what? F capital Q will be K into this Q into this Q, that is Q square upon the net distance is 2r, so its square will be 4r square, will be equals to, now look, the value of a small q will be in the opposite nature of the capital Q. That is, if capital Q is positive, then a small q should be negative, because the nature of force between both the charges, that is small q and capital Q, is attractive. Okay, so you can say that you can write it as minus of K into a small q capital Q upon, you can say it as r square, since the distance between these two charges small q and capital Q is small r. Okay, now you can cancel this K and K, okay, and r square, and you'll get a small q equals to capital Q upon 4 with a negative sign. Okay, so among these options you will get option 4, that is minus q upon 4, as the correct answer. So this option 4 is the correct answer here. That's all for this question, guys. Thank you.